Hi boys and girls, it's Miss Bissell. Today we're going to review multiplying by one-digit multipliers and dividing by one-digit divisors. So what I'm seeing are two preferred methods that you guys are using. So let's start with the multiplication. I see some of you that have already transitioned into the standard or traditional algorithm. And then I see some of you that are still working with the area model, sometimes called the box method. So we're going to work a couple of these in this video. You're welcome to pause it if you want to work them with me and see how you're doing. We're going to start with 563 times 8. So if we use an area model, our multiplier is 8. And what we're going to do is we're going to write, make a box, and we're going to write 563 in an expanded form. So if you remember from 3rd and 4th grade, that's where we know we have 3 ones, 6 tens, 5 hundreds. So we're going to be multiplying the 8 times the 500. Then we're going to multiply the 8 times the 60. And then we're going to multiply the 8 times the 3. So we're going to create this area model to give us our workspace. All right, so the way this works, you guys know a little bit of mental math with multiplying times factors that have zeros in them. So 8 times 5 is 40, and then we annex or add the 2 zeros in the factor. So we get 4,000. 8 times 500 is 4,000. Same thing. 8 times 6 is 48. We have 1 0 in one of the factors that we need to annex. So 8 times 6 is 8 times 60 is 480. And then 8 times 3 is 24. So I'm going to go ahead and say it now. If we don't know our basic times tables, our basic multiplication facts, certainly through the 9s, we need to be practicing those at home. All right, so now we have partial products that we need to carefully add together. So if we add 4,480 and 24, and we carefully add, we get 4 in the ones place. 8 tens and 2 tens give us 10 tens, so we're going to regroup. That would become 1 100. 1 plus 4 is 5 hundreds, and then we have this 4,000. So we get a product of 4,504. Now, the traditional algorithm looks a little bit differently. We take our 563, multiply it by 8. 8 times 3 is 24. Just like adding, you're going to rename your 20, your 2 tens into the tens. Excuse me. 8 times 6 is 48 plus the 2s, the 50. Again, you're going to regroup those 5 tens into, 50 tens into 5 hundreds. 8 times 5 is 40 plus the 5 is 45. Then we get 4,504. All right, let's do one more. All right, if we have 1,234 times 5, don't forget that means we're multiplying. Our multiplier is 5. All right, I just kind of start setting up my box until I see how much space I really need. So here we have 4 ones, 3 tens, 2 hundreds, 1,000. So let's start with the 1,000. I like to skip a space. Then we have the 2 in the hundreds. Then we have the 3 tens for 30 and the 5 ones. And then when I know about how much space I need, I can set that up. All right. Creating our area model or our boxes. All right, here we go. We're going to do some mental math. So I know 5 times 1 is 5. If I annex those 3 zeros in the factor, I get 5 times 1,000 is 5,000. I know 5 times 2 is 10. I have 2 zeros to annex. So that tells me that 5 times 200 is 1,000. 5 times 3 is 15. I have 1 0 to annex, so 5 times 30 is 150, and 5 times 5 is 25. So now I have 4 partial products to add. 5,000, 1,000, 150, and 25. Carefully add my ones. I have 5 ones, 7 tens, 100, 6 thousands for a product of 6,175. All right, let's look at this with the standard or traditional algorithm. So I have 1,235 that I'm going to multiply by 5. All right, let's take a look at this. We always multiply by the multiplier, and we start with the ones, tens, hundreds, thousands, and keep moving to the higher place values. 5 times 5, 25. We've got to rename those 2 tens that I just carried, the 20 as 2 tens. 5 times 3 is 15 plus 2, 17. 5 times 2 is 10 plus 1 is 11. 5 times 1 is 5 plus the 1,000 we carried is 6. All right. So on your independent practice assignment, you can pick either method, whatever you're comfortable with. If you're really good with the area model or the box method, why don't you give the standard algorithm a try? Why don't you do a couple of them with the standard algorithm and see how that works out for you? Now let's talk about the division strategies that I'm seeing. Again, I'm seeing some of you that are doing the box method and some of you that are doing the standard algorithm. So we're going to talk about both of them quickly. So with the box method, it's really the same steps as the standard algorithm, except you're setting it up a little differently. So I'm going to show you the standard algorithm first of all. So we're going to divide 7,243 by 6. And what I like to do is I like to put a little caret marker where I'm going to start my quotient. So 6 will divide into 7 one time. I can make one group of 6, right, if I have 7. And that gave me 6. So when I subtract, I have 1 left over. And I'm going to bring down the next digit. All right, 6 goes into 12 2 times. 2 times 6 is 12. I'm going to subtract. Don't have anything. I'm going to bring down the next digit in the quotient. One digit at a time. Every time you subtract, you're going to bring down the next digit in your dividend. I think I said quotient. Sorry about that. All right, 6 will not divide into 4. If I have 4 of anything, I can't make any groups of 6. So we put a 0 in the quotient. 0 times 6 is 0. I subtract. Bring down that last number in the dividend. 6 goes into 43 7 times. I know that because 7 groups of 6 would be 42. I have 1 left over. So my answer is 1,207, remainder 1. So if I had 7,243 and I wanted to make equal groups of 6, 1,207 would fit into each group, and then there would be 1 left over. All right, now let's look at this with the box method because it's the same steps. Maybe just an easier way for you folks to organize the work. I think that's why some of you still lean on it. All right, this time we're going to take each number in the quotient, the 7,000, the 200, the 40, and the 3, and we're just going to leave it as it is, but I like to skip a space so we have some working room here. So you'll see this in just a second. And I like to leave about 3 or 4 lines to work in. All right, so behind each number, we're going to create our box. And we're going to start here. So just like the traditional algorithm or the standard algorithm, we're going to see how many 6s we can group if we have 7. And wouldn't that be 1? 1 times 6 is 6. Same thing. We're going to subtract 1. All right, now instead of bringing the 2 down beside the 1 to get a new little partial dividend of 12, you are used to bringing that 1 upwards. And now you recognize you're going to divide the 6 into the 12 this time. You can make 2 groups of 6, and that gives you 12. Same thing. And again, when you subtract, instead of bringing the next number down, you guys are used to bringing this difference up, right? Okay. Can't make any groups of 6 if you have 4, so 0. 0 times 6 is 0. All right. Again, you have that 4, but instead of bringing that last digit down from the dividend, you guys are bringing it up. Okay. And then 6 will go into 43 7 times because 7 groups of 6 is 42. And here's that remainder. There's nowhere else to pull it up, right? So this guy right here is your remainder. So what that means, your answer is right here, 1,207 groups of 6 with a remainder of 1. All right. 2 different ways to organize, but really the steps are the same, except here in the traditional or standard algorithm, you're bringing down the next number in the dividend. Here, you're bringing up the difference. So, I think a lot of people do better visually starting out with this and then moving into the standard algorithm. I would like us to be working towards the standard algorithm and getting away from these boxes. But whatever you need to do, whatever your method is, until you get proficient, just for a review handout, I'll take either method. All right, let's do one more. All right, so again, let's start with the standard or traditional algorithm. We are dividing 1,429 by 3. All right, now I know that 3 will not divide into 1. So remember I said I like to use that little caret marker? There it is, because what I'm going to do is I'm going to divide 3 into 14. And I know that 3 into 14 will go 4 times. I can make 4 groups of 3. That would give me 12. When I subtract, I get 2. And then we bring down the next number in our dividend. 3 will divide into 22 7 times. 7 times 3 is 21. When I subtract, I get 1. I bring down the last number in the dividend, and I get 19. 3 goes into 19 6 times. 6 times 3 is 18. I don't have any more numbers to bring down. This difference of 1 is what we call the remainder. So what this answer means, what this quotient means, is I can create 476 groups of 3. I would have 1 left over. All right, now let's look at it with this box method that you guys like. Just a different way to organize the same steps. All right, so when we make our boxes, don't forget, we want to leave space, right? We need that working space. So 1, 4, 2, 9. I really like to spread it out and give myself that room. And then, like I said, I like to go down about 3 or 4 lines. And I'm going to create my boxes. I've got to leave enough space to bring over anything in front of each of these numbers in the dividend. All right, so 3 does not go into 1. I've seen you guys put a 0 here just to keep your thoughts together and your work neat. So this 1 is actually just going to get pulled up. So just like here, my first step was to divide into 14. That's really what you're doing here to get the first number in your quotient. 3 goes into 14 4 times. 4 times 3 is 12. When you subtract, you get a difference of 2. So instead of bringing the 2 down, the 2 tens down, you guys are bringing that difference up. All right, 3 goes into 22 7 times. 7 times 3 is 21. You subtract, same steps as over here, except instead of bringing that 9 down beside the 1, you're bringing the 1 up beside the 9. And then 3 goes into 19 6 times. 6 threes give us 18. You subtract, here's your remainder. So here is your answer. 476 remainder 1, just organized a little differently. All right, so you boys and girls have a handout. You have 5 multiplication problems that are a review of 4th grade multiplication. You have 5 division problems that are a review of 4th grade division. So I'm looking at getting you guys really proficient on this because we're going to be moving into 2-digit multipliers and 2-digit divisors in our 5th grade curriculum. All right, have a great day.